Okay, so another reaction, another form of chemical reaction would be what? Yeah, as the ice melts, it's releasing energy, right? It's kinetic energy because it's reacting with the air, so it's thermal. It's making a thermal change.
Ah, my foot burns.
It's making a thermal change also.
What size are these?
They're really stupid.
No, I've been through this before. But don't take my word for it. You guys should go back in the computer and verify what I'm saying. Because you guys could go back in and look it up and say, okay.
We could see our grades and our attendance on the computer.
Thermal. Okay, so here's another reaction. Okay, so here's okay. All right. So if I took a brick and I poured acid on the brick,
it would dissolve.
And what kind of reaction is that?
Chemical.
It's a chemical reaction that's inducing a what? A what kind of change?
No.
Well, it has thermal components because it's burning it. But what kind of change would it be?
Kinetic energy?
It's not. It's a physical change.
A
Because the brick is going back to the elements that make it a brick. It's not a brick anymore, but it still has the same pieces.
Yeah.
So it's a chemical reaction that's inducing a physical change.
I remember my teacher explaining that to me.
Just like you could take salt
Oh my God,
and put it in water, right? You put salt in water,
The salt
it dissolves, right? Chemical reaction to dissolve it. But it's having a physical change. Yeah.
Ask Eddie.
No, I mean, but the teacher may turn around and say, oh no, that's wrong, but that teacher is not really right.
It's not.
No, he's.
Just tell her to go ask Eddie.
Yeah, they can come back. So, but you guys get it, right? So the ice is releasing thermal energy. Because ice because the ice turning back to water is releasing thermal energy.
Because the ice turning back to water is releasing thermal energy. Oh my god, I put that in the wrong spot. I screwed that up.
Now, go into the computer and find the definition of thermal energy.
We have it right here.
Okay. So read me the definition of thermal energy.
Electromagnetic
I cannot believe it. Computers. Okay, so the total amount of kinetic and potential energy in the atoms of an object, meaning the total amount of what it's doing and what it can do, right? So, interesting about the ice. What happens if we take the same amount of water that melts into the little tray and then put it back into the freezer? Is it releasing energy?
Yes.
Is it? When we freeze it again? Don't doubt it. Don't doubt yourself. Do you believe that it's releasing energy when it freezes again?
Yeah.
It is. Why?
Because the heat is released.
The heat is dissipating, but it's the kinetic energy. The atoms are changing their position, which is inducing energy. It's hardening again. The atoms are moving. It's changing its state. So it's a physical change, and it is kinetic energy. That's why the definition of thermal is potential, okay, and kinetic. Everything that's associated with that atom. The atom never goes away. The atom always exists. It just we're just moving around to do different stuff. Everything is an atom. Every single thing you see is an atom. Your hair, your lips, your eyes, everything you see has an atom of something. We're just moving them around when we do different stuff to them.
Or changing the temperature.
Or changing the temperature. Like if I burn your hair, it turns into carbon. No, but I'm just saying. If I burned a piece of your hair, it would turn to carbon, but then there's carbon atoms that are left. Okay, cool. Yeah, all right. So maybe that was a bigger explanation.